Hello all and welcome back. So in this video, let us now move forward and now write the code for our custom list class. So let us first understand again what we have to do. So we will be creating a class named custom list and we will try that we are able to mimic all the behavior. Okay, so different operations and methods like append, delete, all these methods which are there in my list, I am able to mimic them in my custom list class. We will be implementing this using the C type array. Okay, so there is something which we will use for that. Don't worry. The reference only, the way we discussed in the last class that how the list in Python stores reference. Okay, I want each and every one of you to be very attentive to understand this completely. Now, let us create this class. Okay, so first thing is class custom list. Okay, then let me create a constructor inside this class. In this constructor, we are now going to define few things. The first is going to be capacity. Okay. Now this is equal to the initial capacity. So in the last video, I showed you that how a list also start up with some size. Okay. Maybe it is having two elements or one element. Then it keeps on doubling or increasing that, right? So we will also start with some capacity. Let us say in our case, that is one. Okay. So capacity is one. Or let me just make it initial capacity here so we can refer it afterwards. So capacity is the initial capacity. Then we are going to take a size, which is 0. Now the difference between size and capacity is that capacity is what how much you can store. So let's say after doubling, you can now store 4 elements in your list. Size on the other hand is how much are currently there. How much are stored right now. Okay, stored right now. Okay, capacity is how much we can store. Okay, intuitive and easy way to understand this. Your capacity is, let's say you can eat 3 burgers. Size will be that you have just eaten one as of now. So if I append one element into my list, that means the size is one, but capacity will still be 4. It is how many the list can store. Okay, great. So now let us go back. Now I have to create internally an array. Okay, so I'm just like giving it the name array. And this we have to make sure that here we don't have to create a list. See, the whole point is that we don't have to use this list. We are creating our own list. If we are trying to use list, that is not right. So for this, what we are going to do, I'm going to import a class which is known as ctypes. So ctype is a library, not a class, which helps you to create Python C specific data types. Okay, so the one which is compatible with C language. Now again, you don't have to understand a lot on this behind. We will just use it to create a array which will be having referential objects. So for that, let me just create a function and I'm going to make it private. Create array self dot capacity. So all I'm saying in this function is that create me an array. Okay, so create me an array of this particular capacity. So I will be getting self here and I will be getting the capacity here. Okay, capacity. Great. Now what it has to return, it will be returning something like this. So C types dot py object. Okay, so this is just something which is saying that hey, the C type is the Python reference object and capacity into this. All this does is just return you a C type referential array. So in this you can store references, just what Python does. Okay, so let me write this as well. Create a new array with given capacity. Okay, and it's not any array, it is having a referential array. Now this is something which you can just for the time being take again in coding. it is always a learning journey. So don't get like if you don't know this. This is something which we will see. You will not be using this going forward. Just for this particular implementation, we want to avoid using list because we cannot implement list using list, right? So I am just falling back to C type the way it is actually implemented. Okay, great. So once we have created this array, everyone, now in the memory, we will have a referential object overall of a capacity 1. Okay, so in the memory, we will have something like this. The list will have something like this, which will be a reference array. So you can have any reference here, something which we talked about in the last video. Great. So now let us move forward and try to append the objects because we have to make sure that we are able to append anything, right? So for the time being, let us just see the working here. Let me just comment everything above. Let us comment everything. You can uncomment it. See, L2 is equals to, or let's say L1 equals empty list. I can append in my L1 any object. Let's say I append 1. If I now print L1 and if I run this, we will see 1 here, right? So now let us go forward and implement append. Great. So self and item. Now when you append, you will be sending an item as well, right? So this 1 was the item which I'm sending, what I want to append, right everyone? So let us just understand these each and every function one by one. The very first one which we are implementing is the append. And you give me an item to append. So it is going to be something like this, append, right? Now in the oops, we have learned that how we can create our own methods. And this is just what I'm doing. This will be the first time you might be going a lot complex. Or rather, I would say that in the questions, you must have in the complex number. So this will be a lot understood. Okay, great. So append, what I will be doing. First thing I have to make sure before appending is to check if the size is there. Okay. If the size is there, then I have to first check if I can, if overall the capacity is not full. For example, let's say I want to append and the capacity is full. You cannot add anything then, right? So for that use case, what I have to do, if self dot size equals self dot capacity, then I have to do something, right? What we have to do, we have to resize our array. If you remember from the last discussion, we were doing something like resizing our array. So for that, again, I'm making a inbuilt private function. Sorry, not inbuilt. I'm making a private function in which I will just send the double of capacity, right? What will this function do? Let us see that. Def resize. Okay. It will get a self and it will have a capacity again. Okay. So let me explain what exactly do we mean by this. Pay attention. Let's say you have a overall list which internally has just two spaces. It is 1 and it is 2. The size is 2, right? Now, if I ask you to append 3 here, if I want to append 3 here, you cannot do that. What we have to do is we have to make or resize this. So we will be resizing it to size 4. Once I have resized it, then I will be copying these elements, right? So something which we discussed in the last video, I will be copying these elements. So this is 1, this is 2, and now I can add 3 as well because the size or the capacity has now become 4. Here the size was 2 as we have 2 elements and capacity was also 2. So I can say that when my size is equal to capacity, my overall element gets filled. Oh, sorry, overall array or this list gets filled. Okay, so this is what happens in the backend as well in list also, that when it has reached its size, then we have to make sure that we are resizing it. Something we saw that when the size was increasing, right everyone? So let us now write the code for resizing. Let us go back to VS Code. So for resize, what effectively I have to do is I have to first create a new array, right? So I will be creating a new array in which I can just use the previous create array one which I used, right? So create array, let me zoom it out. create array. This time I just have to pass the new capacity. Okay, so let us make it new capacity and let us follow the underscore convention. Great. So now I have passed the new capacity. Now in the memory, I have this 4 sized array, right? Now what I have to do, everyone? I have to just copy each and every reference. So for I in range, again, we are using the simple for loop, self dot size, because size is having exactly everything. New array of I. Again, this is an array which is exactly going to work. So we have this access, and we can actually access anything in this and even change that. So self dot array of I, right? So all I have done here is, everyone, I'm just now going to 1, copying it, going to 2, copying it, doing till I go to each and every element via this size variable. Once this is done, then what I have to do? I have to say that, hey, now the array which you are maintaining, it is this one. So in our self, we were maintaining an array which was earlier pointing to this, right? Now I have to cancel this particular connection and say that, hey, point to this instead. Okay, because now I have resized my array. So self dot array equals new array, replace the old array. Along with that, I have also increased my capacity. So self dot capacity equals new capacity. Okay, everyone. So we have done this resizing. Just we have copied everything and we are now good to add any element. Once I am here in append, let us see what exactly is going to happen. So when we start initially, we will be having a single space array, right? And the index will be 0. And we are also having a size which is 0 initially. So the idea here is that I'm going to use this size to append things to my array. Okay. Now, first we will be appending using this particular formula. So array self dot size. So this size will have index where I can add things. And if you think about this, this is perfectly well, because size will always be equal to some integer. So it will be 0, 1, 2. It will have 0 value in the starting. And index wise also, it starts from 0. Right, everyone? So in Python as well, the indexing is from 0. So if I print L1 of 0 here, then pay attention what happens. I'm getting just 1. Now 0 is how many elements initially I have. So self size is 0 initially, right? So what I have to do, pay attention, everyone. Self dot array, self dot size, which is 0 initially, equals the item. So I have added the item here, and now I can increase my size. Now the next time, if you will ask me to add anything, what's going to happen? Let's say we have size of 4. So 0, 1, 2, 3. In the first space, initially my size was 0. So when I added 1 using this. And now I have increased this through 1. When you ask me to add anything in the next attempt, when you ask me to append anything, I will now point to this index 1. And similarly, I'm going to increase it. I will keep on increasing it till it becomes equal to capacity. And once it reaches capacity, then we resize it. Okay, so great, everyone. Pretty sure that this will be clear. Let me remove everything now. Great. So this is how append is going to work. Right, everyone? So we can just try one thing out as well right now. What we can do is we can create my list equals custom list. So I'm creating an object of my custom list class. This is what you have studied in OOPS. Now my list dot append. I am seeing an append function and I can append things into this. So my list dot append to, and I can now print my list. So the printing will not work as of now. We are going to write the code for that, but let us see. What we can do is we can write a length function. So if many of you are aware, there's a length function, right? How many length is there? Now internally, this length function works with a magic method under underscore length. Now, many of you might have an idea that what magic methods are. So let us move forward and now think about second function, which is your length function, right? How are we going to implement length? In length, it calls a magic method which is under underscore length, right? This gets called internally whenever you call length on any object. Now, Python doesn't know what it has to return. Each and every class has this particular length implemented. Where can we get the value, everyone? I feel that we can get the value very easily from the size we are maintaining. The size is something which we increase when we add anything. We will decrease when we remove anything. So by that logic, it will have how many elements are there in my list, right? So let us do that. Let me first prove to you that this is something which gets called. Okay, so self and print. All I'm doing is right now just printing something. Give me the logic and I will tell the size. Okay, so you will see this particular string printed now. So let us run this now, everyone. We should see this particular string uh, when we call this length function, right? So let us run this. Okay, so it's giving an error. None type object cannot be interpreted as an integer. Okay. Well, the reason is, yeah, we are actually not returning any integer there, right? So let us just return -1 for the time being. And let's run this now. Okay, yeah, my bad. Length cannot be negative. So let us return 0. See, it is printing give me the logic and I will tell the size. And it is printing 0 because that is something which we have returned. Okay. So this proves that whenever you're calling this length function, internally it goes to this magic method. Okay. Great. So now let me just remove this and let us just return self.size. Okay. Now the reason we are doing this via length because we have not implemented the print function as of now. So if I will just print my list, it is going to give me the address and say that, hey, it is an object of this type. So let us run this now, everyone. And see, it is saying that, hey, this is a custom list object at this address. So if you remember that 0x was used, right? And the length is 2. Great. So I think this is working fine. Now let us do one thing. Let us now move forward and try to implement the print function as well. So we can see our list. There is a magic method again, which is str, okay, in which we have each and every, which is getting called every time you do the print on any object. Okay, so internally in every class, this is the way you are able to see this, see the overall output, right? So when I do print list here, when I do print L1, ideally the code goes to that str magic method in string class, the one which have been made by Python, and then you see this finally. Okay, so let us go back and implement the same as well, everyone. Great. So it should return a string. Let us say that it is result, or let's say output. Okay, so my output is an empty string initially. Okay. Now what I have to do is I have to create my output, right, everyone? So what I can do for I in range, again, self.size, I'm doing. In this size, output is equals to output plus whatever is stored in my array. So self.array of I plus this comma. Okay, and let me just return this output to show you what we have created. Output. So pay attention, everyone, what we will see in the answer. It is giving me 1 and 2. So there are two things which are wrong. Once we are not seeing that square bracket, which accommodates like every time you see in a list, and this extra comma is also there. So for square bracket, again, I can just use something like this, right? See, now I'm able to see this in a square bracket. And for this extra comma, what I have to do is, pay attention, everyone. Let's say if I have a string which is Python. If I do S this, so this is slicing. You must have studied this in your earlier videos where we were using slicing, right? So you will get the whole string. Let me run this again inside print. minute, yeah. So it is the full string. If I add -1 here, it is not going to take the last, this n. See, it is giving you pytho. N is not there. In a similar way, my output, let me zoom it out. Yeah. My output right now is having that extra comma as well. So to get rid of that, what I can do, just everything except the last character. And now we are able to see this exactly in the way we see it in a string, right? So if I run this here as well, if I run this particular part, see, it is 1 inside this, right? So similarly, I will be able to now see everything just the way a string shows us the output. Okay, great. So now let us move forward, everyone, and try to implement the pop function. Okay, so in our list, we have a print L1 dot pop. Okay, let me make the list something like this: 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, let us get rid of this. Now pay attention, everyone. What's going to happen? Let me just move it above. Great. When I use pop, it effectively is remove the last element from my string. Okay, so let us run this. See, 1, 2, 3, 4, 5. And it is giving me 5. Initially, the string was this. So let us understand a little bit more on this as well. Third overall method which we have to implement is something known as pop. Now, what pop does is it removes the last element and give it back. So it removes and give it back as well. Okay, so that you can use that. That is what pop does behind the scene. So let us try to implement it now, everyone. There is one more very interesting thing about pop. If you give it an empty string, right? An empty list, like nothing is there, and you are asking it to remove something, then that is also a problem, right? So let us run this and see. It's giving an error. Index error, pop from an empty list. Right, everyone? So pretty sure that this would be clear. You cannot remove anything from an empty list. Now let us see how can we do that. Okay. Let's say I have a list which is having 4 elements, something like this. So 1, 2, 3, 4. The indexes will be 0, 1, 2, 3. Size will be, let's say, 4, and capacity size will be 4, and capacity is minute, yeah, capacity is 4. I believe that using size, okay, I can get this particular last element. If I just do size minus 1, size minus 1, then this will point me to the last element. If it will be 0, that implies the list is empty. And again, then if we do try to access the -1 element, that will give me an error. Right, everyone? So with that logic, we can implement that. We cannot use capacity. I have taken this example specifically to remove that confusion, because tomorrow it can happen that capacity is high. Capacity can be 8 as well. So we have to use size, okay, not capacity. Great. Let us see this in action then, everyone. So next method is def pop. Okay. In pop, again, I will be getting just the self. I don't need any index or anything. If self dot size is 0, if there are no elements, that means we should say empty list, and we can even copy this error as well, so as to show the same error, just to keep the differentiation so that we see this particular list. Great. If that is not the case, then we have to first get the popped item. So popped item, again, it is equals to self dot array and self dot size minus 1. I have this. Now to remove this from my array, what should I do? Pay attention, everyone. if I just do size equals size minus 1, I think it will remove the element. How will it remove? Earlier size was 4. This implies size will become 3. So next time I will be just focusing on this much of my array, right? I will not be focusing on this last element. Yes, it will still be kept, but I don't care. Okay, so tomorrow if my overall array is this big in size, and let's say I just have stored till 2 here, and the size here I say is 2. I just have to focus on these elements. I don't care what exactly is stored in this particular location because I just have to go till size, right? Capacity can be bigger. That is not my concern. On the same note, you will see that in the print, the str magic method, we were using this size only, right? Not the capacity. So self dot size equals self dot size minus 1, and I can just return the popped item. Great. So let us try to check this out quickly, everyone. We have printed my list here. Then what we can do, my list dot pop. Okay. And then instead of length, let us see the list only. And then again, my list dot pop. Let us see the list again. And finally try to do this pop on an empty list. So I have added 2 elements, everyone, 1 and 2. Then I'm printing the list. Then I pop, print it again. Then pop, print it again. And finally popping on this empty list. Okay, so let us run this. Okay, so it is giving me an empty list here. We have returned this error, right? So we have popped 3 times. Okay, my bad. We have to print the list as well. 1 minute. Okay, so it is printing the empty list. Maybe we should print this error. Print this particular error. Okay, I get the reason. So the reason for that is we are not printing this. So we can print the pop as well, right? It is going to print exactly what we are sending. So we also return the element, right, everyone? So the return element get cache here. And if we run this now, see 1, 2, I'm getting 2. Okay. 2 is the popped element. Then there was just 1. When I pop, I'm getting 1. Now when I'm printing my list, it is an empty list. But now if I try to pop something, it is saying empty list index error prop from an empty list. Okay, so I hope this is clear, everyone. Let us just return this only instead of printing. So let me return this only. Now it will be all fine. Pay attention. So this time what happened? I asked to create a list. Here, my list would have been created. Then I added 1 and I added 2 here. After that, I printed my list. So this is the list. Then I popped. So 2 is removed and it is returned as well, right? So this is how our printing is happening. Then I'm printing my list again. This time it is just 1. I asked to pop. This time what will happen? I will get 1 and 1 will also get removed. Now when I ask to print the list, I will just be seeing an empty list. And finally when I do the pop, I see this error. Empty list, index error, pop from an empty list. Okay, we were not printing this. So whatever we were getting in return, we were not saving that anywhere. Okay, cool. I think yes, the pop functionality is also working fine. Now in the next video, we will implement the rest over methods, which are the clear, find, insert, and delete. I'm pretty sure that you will have a good sense now that what exactly is happening. So seeing the behavior of my list here, I am trying to just implement the same behavior, exact same behavior in my custom list by using the concept of oops. Okay, this is very, very important to understand. So just make sure that no doubts are there till now. And in the next video, we are going to implement the some of the left